In last class we have demonstrated the measurement of Young's modulus of a material. In laboratory we have seen that we took a bar of is a material was basically brass. So, this we have showed how to find out the Young modulus, basically how to take data for this experiment. So, we have demonstrated the measurement in laboratory. Now, let us analyze the data and find out Young modulus and error on this measurement. So, we have used basically flexion method, and the working formula for this method is y equal to g L cube by 4 b d cube m by L, right. So, L is basically the length of the effective length of the bar, basically length between the two sharp edge, knife edge on which we kept the bar, and B is breadth, D is depth of the bar, and basically m by L. So, experimentally main part is to find out m by L. So, method we have used that is flexion method, but here to find out m by L, basically we take help of graph. So, we use different mass and measure corresponding depression. So, then we will plot L versus m, and from that plot we will find out the slope of the curve. It will be straight line basically, because this relation is telling that it will be straight line, and from that slope is basically m by L. Okay. So, we have to measure L, B, D as well as this m by L, small l. So, we used meter scale for measuring length L, slide calipers for measuring breadth B, screw gauge for measuring depth D, and travelling microscope we have used for measuring depression L. Okay. So, that how to use this travelling microscope for measuring depression, that we have showed in laboratory. So, now we have to proceed to analyze the data, or basically in laboratory I have shown you the instrument and describe how to take data. Now we have to note down all this data and analyze it, find the result, right. So, that is what I am trying to do here. So, first we have to find out the least count of the instrument whatever we are using in the laboratory. So, for measuring length we have used meter scale. So, for meter scale what is the least count? One smallest division, main scale division of the meter scale. So, that is the 1 millimeter basically, whatever scale we used. So, there is 1 millimeter. So, that is 0.1 centimeter. Then we use slide calipers. So, least count of such slide calipers is basically we tell vernier constant, and definition of vernier constant, you know, this one smallest main scale division divided by number of vernier scale divisions. Okay. So, one smallest main scale division is 0.1 and total vernier scale division was 10. So, your vernier constant is 0.01 centimeter, and you have to note down the zero error also. So, in our case 0 error, it was nil. So, next tools we used, that is screw gauge, and least count of the screw gauge is defined as the pitch of the screw. What is pitch of the screw? Now, one complete rotation of the circular scale, see in main scale, linear scale, what is the reading exposed, means this circular scale and this linear scale. So, if you rotate this circular one, so that reading basically it exposed, it shows initially it was 0, then it exposed to 0.5 and then 1 millimeter, 0.5 millimeter, then 1 millimeter, then 1.5 millimeter. So, linear scales are there. So, that is for one complete rotation, what is the reading. So, that is basically the pitch of the screw. So, in our case for one complete rotation, this it was 0.5 millimeter linear scale, that pitch of the screw 0.5 millimeter means 0.05 centimeter. Okay. And number of division was this 50. You see this, you can do mistake, but you should be just cleanly just cut it and write. Okay. So, do not avoid to overwrite it. Okay. So, just if any mistake, just cut it and write in a proper place. Okay. So, this screw gauge, that least count is 0.001 centimeter. Okay. And then we use travelling microscope. So, it has two scale, one is vertical scale and another is horizontal scale that I showed you. So, in this case for measuring diffraction, we will use basically we have used this vertical scale. Vernier constant is basically same as slide calipers. The scale has vernier scale. So, vernier constant in this case, this smallest division was 0.5 millimeter, means 0.05 centimeter, and vernier division was 50. So, this vernier constant is 0.001 centimeter. Okay. So, whatever tools we used, so just we find out the least count, we noted down all of these things, and then you should note down the temperature of the laboratory, because the Young modulus, most of the parameter depends on temperature, at which temperature you are taking reading. So, it is always it is better to write the temperature of the laboratory. So, in our laboratory it was around 30 degrees centigrade. So, for now we have to measure L, then B, D, right. First let us measure breadth and width first. Breadth and width, let us measure breadth and width. Okay. So, table 1 we are noting down the breadth of the bar we measured by slide calipers. So, on the top of the table you should write the vernier constant for this slide calipers. So, already we have calculated, and there is a 0.01 centimeter, and then number of table you should make it like this: number of observation, reading of the main scale and vernier scale. Here I have written this in bracket, this unit. If you write here on top of table means here. So, we do not need to write 2.6 centimeter, 2.5 centimeter, 2.5 centimeter. So, it is not looks good also, and to avoid writing repeatedly. So, if you write on top of it, so then it means that this readings is in centimeter. Then total reading of B means main scale reading plus vernier scale into vernier scale reading into the vernier constant. So, data is should be available here vernier constant. So, you are writing total reading of B, and then you are finding out the mean value of B. Okay. So, here as I told in laboratory that you should take few reading, okay, not just one reading. So, always repetition of the measurement, repetition it's reduce the statistical error. Okay, it helps to reduce the statistical error. So, instead of measuring just once, generally we take few times. So, it can be 3 to 5 times. Okay. So, and another reason also this the scale is length is around 1 meter 100 centimeter. So, its breadth may not be perfectly uniform everywhere. So, that is why we should take in 2, 3, 4 places and then take average. Okay. So, that is the reason also here we have taken 3 observation. So, this is the main scale and there is a vernier scale reading and this total here. If you take average of this, so it is a 2.593. Okay. Now, you should not write 2.593 because you can demand accuracy only up to 2 digit after decimal point. So, that is why you have to keep up to 2 decimal point. So, here we have written this should is basically 2.59. Okay. So, you know this how to write the significant digit, okay, as we describe. Okay. So, here it should be 2.59 not 2.60, okay, because it is 3. If it is 5 or above 5, then only it could be 2.60. So, then second table is for measurement of depth of the bar by screw gauge. So, least count of screw gauge you should note down, and then again that is in 3-4 places you should take reading, and here same way this reading of the linear scale, number of division in circular scale, total reading and then mean reading. Okay. So, I have not just here just written the reading, but just I have written the here average or mean value of the D. It is in our birth, so it is 0.666. So, 3 digit we have taken because here we have 3 digit after decimal. Okay. So, 3 significant digit of course. So, this is the mean value of the D, and then now so again in working formula you have seen that we have basically 4 parameters. One is length capital L, then breadth, then depth BD, and then depression L small l for different mass. Okay. So, wherever we have scope, always we should take more than one set of data. So, we have taken bar. Now, among L, B, D, these 3 parameters, whether we can vary one parameter or not, that whether that possibility is there or not in the experimental setup, that you should find out. So, in the procedure we have seen in the laboratory that B and D we cannot vary for a particular bar, but we have scope to vary the length capital L. So, that is why we will do the experiment for more than one length. So, generally we take 3 length. Okay. So, and then for each length you have to now you have to find out M versus L. Okay. So, for different mass we have to find out different length. Okay. So, that is why here this table number 3 very important table, main table of the experiment. So, here length of the bar in centimeter. So, for length 70, 80 and 90 for 3 length we have done experiment. So, for each length say for 70, now mass, for how many mass you should take depression. So, as I told, depending on the method, okay, how you want to find out the M by L, that value. So, we will use graphical method, that we have decided. So, if you use graphical method, so you need at least 4 to 6 readings. So, here in our laboratory we have taken for 5 mass. So, number of observation for each length, now number of observation is 5. Okay. 1, 2, 3, 4, 5. So, each observation we are taking reading of depression length, this small l depression for different masses. Okay. So, for basically 5 masses, and then that also what are the possible, that we have to find out how we can repeat the measurement, how we can increase the set of data. So, all the time, because this reduce the statistical error. Okay. So, in this case again we have scope. When we are increasing mass, then we are measuring the depression, and then other things also we can do, that just we are decreasing mass, during decreasing of mass also again we are taking reading. Then we can take the average of this two reading. So, thus we are increasing the number of sets of data, okay, which all the time wherever the possibility is there. So, one should use this this opportunity to reduce the error, mainly repetition of measurement or reproducibility of the result. Okay. So, it is all the time it suggests that one should take as many as sets of data possible. So, here within our experimental geometry, so this is the load, and from microscope we are taking reading. So, here we have 2 column, one is for increasing load, another is for decreasing load. Okay. And then we will take mean reading, taking average basically from these 2 reading. So, here mass, when mass is 0, okay, we are not putting any mass. So, initial reading is 5.35, vernier is 0, then total reading is for this mass in kg. So, this reading is 5.350. So, that 0 you have to write, because here vernier constant is 0.001 up to 3 decimal. So, here we have to write up to 3 decimal point. Okay. So, so now what we are doing, we are increasing the weight and then taking reading. For each mass we are taking reading. Okay. We are writing calculating the total reading when increasing the mass. Now, here I have written, you see the same reading here basically. So, now we are taking, this is the starting point. For increasing load we took, this is the starting, okay. Then we are increasing the mass, taking reading. Now, decreasing the mass. So, this is the starting. Now, we decrease the weight from 2 to 1.5, just remove 0.5 kg, okay. Then take reading, then 1 kg, take reading, then reduce again 0.5 kg. So, now it is 0.5 kg, take reading. Now, again this 0.5 kg you remove it, and then we are coming back to the 0 kg for this whatever the reading. So, these two reading are not same, it's a different in vernier, generally it should be. So, this I think measurement is very appropriate, and this way also one can find out whether any mistake we have done or not during taking reading. So, that also one can cross check from this data. So, basically for each mass now we have 2 reading, okay. We have 2 reading, and then we have to take basically the average of these two. So, that is the mean reading, we have to take the average of these 2 reading. So, that is what this column, okay. So, this is in centimeter. Now, depression, here we have written L1 minus L2 or L2 minus L1, just to keep it positive value. So, so at 0 mass, so this is the reading. So, this is the initial reading basically, it either L1 or L2, whatever you consider this one. Now, from this reading, since this reading here decreasing, here reading is decreasing, okay, here reading is decreasing. So, from this actually now I will use this column. So, so if you take it is a L1 initial reading minus L2 means this reading. So, so here I have written 0.000. So, here for 0 mass basically. So, we have to here basically this we have taken initial reading. Now, if you just minus this reading, so it will be 0. So, this for 0 mass, okay. So, that basically in instrument we are not able to start from the 0 reading. So, here if you just minus this initial reading, so then basically you are calibrating with the as a 0, okay, 0 reading. So, then next for when we are putting this 0.5 mass. So, for this what is the depression? So, this was the starting reading, now minus this final reading or vice versa, this reading minus this reading or this reading minus this reading. So, that is why L1 this way we have written, its meaning is that either L1 minus L2 or L2 minus L1 depending on this which value is higher. So, here it is higher value, okay. So, from here, so if I just minus this one L2, if it is L1, so L1 minus this L2, so this is the reading. So, this is for 0.5 kg mass, this is the depression. Now, this reading minus this reading, okay. So, this will be for 1 kg. So, minus this reading, it will be for 1.5 kg minus this reading, it will be for 2 kg. Okay. So, now I have the reading L basically for different mass m here. So, for length 70. Okay. Similarly, now take length, effective length 80, repeat the measurement in same way, repeat the measurement in same way, take reading length 90 and repeat the measurement in same way. Okay. So, now for 3 length you have breadth and width, of course same for all measurement. Now, you have 3 sets of data. For each data, for each set, okay, we have to draw graph. We have to draw graph L versus M. So, if you draw graph, so I have graph paper basically. So, you have to draw graph. So, one scale you have to choose, one scale you have to choose, I think. Okay. This is the mass in kg or gram, whatever you should write, and this is the depression. I think you should write say centimeter and this kg. So, now for I have 0 mass, then 0.5 kg, then 1 kg, then 1.5 kg, then 2 kg. Okay. Now, from this so here you have data, for each mass you have data, right, you have data, this depression L. So, that you should plot, So, this will be one point and this other point, just you have to find out, take the scale properly and you have to plot. So, you will get 5 point. Okay. So, find out the average curve. Similarly, this say for 70 centimeters length. Similarly, you should draw for other length. So, other length we have chosen this 80 and 90. So, for other length also you should plot in same graph or different graph also you can use. So, you should use different symbol, Okay. So, then you plot the graph. So, it is not straight line, so one should use scale and I think you should draw properly, Okay. So, it may not pass through the 0 exactly, but that will be basically error. So, similarly for this for 90 centimeter and in between you are getting for so different symbol you are using, right. So, from each just you find out the slope, you should find out the slope. Okay. So, this basically delta L and this is delta M. Okay. From here you should find out. So, you should find out this value, right. So, similarly from each graph you should find out the slope, from each graph you should find out the slope. So, your in working formula it was now what we should do, we should calculate the Young modulus. So, for that you can make table. So, you make table. So, say table 4 calculation of Young modulus. So, for each length for 70 del m by del L, as I told here del L by del m or in graph whatever the way I have plotted it is slope is giving del L by del m, but just inverse also you can find out del m by del L as you need in your working seeing the working formula, you can decide whether you will. So, slope basically del L by del m, not del m by del L. So, but in our working formula we need del m by del L. So, you should not write this is slope, okay. It is the inverse of slope. So, you can find out from this graph. So, this del m by del L unit you should write gram per centimeter or whatever, this from graph. So, from graph you find out this value. Now, breadth, depth is there, and then Young modulus, this is the formula. Okay. So, you have all data. Now, you just calculate and find out the Young modulus for each length. Okay. And then take average of this Young modulus of these 3, and this average is say coming 9.69 in our case into 10 to the power 10 Newton per meter. So, unit here now I have written Newton per meter, although other unit is in centimeter. So, one has to convert it. So, here I have written 96.9 to 10 to the power 9. Why? Because now this material is brass, as I told you. So, just from standard data you find out from internet, I found this value for brass. What is the Young modulus? Young modulus is, there is a range given 102 to 125 into 10 to the power 9 Newton per meter square, is also gigapascal, 10 to the power 9 Newton per meter square equal to 1 gigapascal. So, people write also 102 to 125 gigapascal, means gigapascal. Okay. This one can write also 102 to 125 gigapascal. Okay. So, here, so to compare with this true value, so that is why I have written in the same format into 10 to the power 9 format. Okay. So, our result is quite good, because this is 102, and this why is the, one has to understand why this the range is given, because brass is not a pure material, it is the basically alloy of different material. Yeah, I did not remember exactly the composition of this brass. I think zinc, copper, etc. there. So, in which percentage it is there, depending on, because the mixture is the alloy of 2-3 materials. So, that is why depending on the percentage of this individual material, pure material, so it will have different value. So, one have scope to adjust the composition in this brass. So, if you want higher Young modulus, so that way you can choose your composition such that, so it should go towards this value 125. So, this is the reason this range is given, because composition of individual materials in brass is not fixed, one can vary. So, that is why it will be in this stage. So, our result is very close to this true value. So, this way one should, if true value is available, one should compare and show this how good your result. Our result in this here the difference is how much? Difference is basically say 5, it is a 97, 100 to 5, okay, 5 into 10 to 5 in this range. Okay. So, 100 plus minus 5, 100 plus minus 5. So, this is the difference. So, this 5% error in the measurement, if you compare with the, not in the measurement, I think difference between the true value and this is the difference is 5%. Okay. So, now we have to find out the error in our measurement, percentage error, or we tell the most probable error. So, error analysis, this is the working formula, and all are in multiple division. Okay. So, you know this relative error will be added. So, del y by y, so del g by g, etcetera. Okay. So, for each term it will be added. So, following the rule I have written del g, del 4, del m, g m are not measured in our laboratory. So, error is 0 on this parameter. Okay. So, now del q, you know, dq by if q is a function of x, dq by dx delta x. Okay. So, that is the rule you have learned. So, from there you can find out this. Similarly, for d also same way. Okay. If you put this one here, so I can write 3 del L by L del B by B plus 3 del D by D plus del L by L. Now, here I have written 2 because this is the difference of 2 reading, you know, L equal to L 1 minus L 2. So, now this is the L 1 minus L 2 del L. So, absolute value will be added as per rule. Okay. So, delta L equal to delta L 1 plus delta L 2. So, basically the error is same on this. So, it is twice of this error. So, that is why this 2 is written here. So, now just using this formula you calculate del y by y. So, for 3 error you will 3 sets of error you should calculate. One is for 70, then 80 and 90 centimeter, B and D is same, and from graph you just take one dictation delta L, choose one L and then use that L. So, from graph you find out L, just choose one L and that L value use for your error calculation. So, you will have 3 sets of del y by y, find out the average. So, I have just written our result using our result. So, this is the delta average one del y by y is coming like this. Okay. Now, del y is multiplied with y. So, this is coming 1.52133 into 10 to the 19 9. Okay. So, answer or result you should write y equal to 96.9 plus minus. Here you see as I described earlier. So, you cannot write 1.52133. So, how many digit you will keep? So, here since you know result it is up to 0.9. So, here 1 decimal point we have used, here also you should keep 1 decimal point. So, if you keep here one more decimal point, okay, so up to which you will keep here. So, actually B, in the B we have used 0.01, D 0.001 and but for L measurement we have used 0.1. Okay. So, among these, so this is the highest possibility of the errors. So, among these, so our least count is in this case. So, if you are multiplying during result you are multiplying all of them, and when you will keep the significant figure. So, you will see basically you know the rule, this how to after multiplication of 2 digit 2 number. So, how to keep this. So, this significant figure in the final product. So, that depends on this if it is 1 decimal point. So, minimum I think this out of 2 which is having minimum number of digit. So, that many number of digit you should keep in the product result. Okay. So, that way you will find out that only you can keep up to 1 digit after decimal. So, that is why you can keep only 1.5. So, if it is 2 up to 2 you can write 1.52. So, here result you have to write 96.90. Okay. So, this should be after decimal, this should be same for both cases. So, here is consistently I have written. So, this is the way one has to write answer or result. Okay. So, from this analysis I think how to make table, how to write data, how to find out the average, keep the significant figure, how to calculate the value, okay, and then finally how to find out the error. So, that's what you learned. So, I will stop here. Thank you for your attention.